Hello, STEM fans. My name is David Alexander,
And I'm Deb Baggett.
and welcome to NASA STEM Stars, where students connect firsthand with NASA subject matter experts such as engineers, scientists, and innovators.
In the past several weeks, we've had conversations with several NASA experts on advanced air mobility, or AAM, which has led us to our culminating panel discussion in our program.
Now, today is no different. We're changing the world and connecting with subject matter experts across the agency to continue our discussion on AAM and, of course, the future of air transportation.
David, why don't we have our guests introduce themselves and share a fun fact that we may not know about them?
Sounds awesome.
Hi,
We'll start with
everybody.
you.
My name is Julie Blackett, and I'm the lead resource analyst for Advanced Air Mobility Project and Mission. I reside at NASA Glenn Research Center in Cleveland, Ohio, and I'm responsible for a multi-million-dollar project and mission budget, which includes 4 research centers and NASA headquarters. Fun fact about me, in 2015, I had the opportunity to attend a 500-year family reunion in a place called Rosigno Vecchia, Italy.
Hi everyone, my name is Andrew Lind and I'm a research aerospace engineer at NASA Langley. I work in the aeroacoustics branch there to measure the sound of these advanced air mobility vehicles. And a fun fact about me is that in college I got my private license to fly fixed-wing aircraft.
Hi, I'm Nikki Pettingill. I work at NASA Langley Research Center. I'm a research aerospace engineer. I also study the noise that is associated with these vehicles. Here at Langley, we're able to test the rotors that you would find in an aircraft in wind tunnels and hover anechoic chambers. So I'm able to help take some measurements and use these measurements in order to characterize the noise. Fun fact about myself is that I love to roller skate, and that's why I have my roller skates here on camera.
Hey, NASA STEM Stars. My name is David Zahn. I am assigned out of NASA Ames, but I work at the Mike Monroney Aeronautical Center in Oklahoma City with the Federal Aviation Administration. I'm the principal investigator for airspace theory at the Advanced Air Mobility National Campaign subproject. And basically, we look at climb and descent gradients and takeoffs from different points in space for urban environments for this new advanced air mobility use case. A little fun fact about me, I went to a different school every year of my life up until my sophomore year in high school. So I love learning and love meeting new people and excited to be here. Thank you.
Wow, everybody, welcome to the program. You're so talented and have such a great wealth of experience. Now, it's been a couple weeks now, but we have all of our STEM stars here to give us a jolly good program here. But Julie, why don't we take a step back for a second? Let's give a quick summary on what advanced air mobility is and probably bring our fans up to speed on NASA's goals related to these flying aircraft.
Sure, David. AAM is the future of transportation, possibly saving 1 billion people an hour a day. Along with travel by plane, bus, train, and car, AAM will add an additional mode of transportation. Think of it as a lower altitude air highway. You will see an electric vertical through the city and landing in another location, perhaps on a rooftop or at a vertiport. In the future, some might be piloted, some not, or autonomous. Currently, different companies are building these aircraft and flight testing them. We are working closely with the FAA to ensure these vehicles can be certified and are a safe alternative of transportation. This new disruptive technology, these new passenger carrying vehicles that you'll be hearing about today, will change how people move around the city and even from city out to more rural areas, alleviating congestion on the ground, how we move cargo quickly and efficiently, making this new transportation option becoming part of our everyday life.
Wow, it sounds like an amazing vision on this end. What what do you guys think about in terms of this futuristic transportation system? I mean, when is it going into effect? Maybe David Zahn can give us some insight.
Well, yeah, David, we're partnered with several industry stakeholders as far as vehicle manufacturers and airspace service providers. And some of them have very aggressive timelines for this integration, and some of them are a little more conservative. So some of the aggressive partners are advertising a 2025 implementation of this ride sharing service. Some of them are more 2030s. And then some of them are even into the 2040s. And so what we like to do is look at different levels of autonomy, and that's humans in the loop of the operation, over the loop, or out of the loop of that operation. And so that kind of equates to those different maturity levels and different levels of expectations on what the operation is going to look like and how people are going to interact with these vehicles in the future.
2025 seems just around the corner. Um, I mean, are these transportation, uh, is it basically going to be more affordable?
Yes, David. NASA and industry are currently working together to make it scalable and affordable for everyone. So NASA's vision of advanced air mobility is to help create safe, sustainable, accessible, and affordable aviation options for a number of uses at local and regional levels. So many of the viewers today may ask exactly how affordable. Initially, these flights may cost, like, let's say $350 a ticket. However, the goal is to have it become another transportation option for the everyday person. So based on preliminary estimates, let's say a 40-minute car drive today would be a 5-minute eVTOL flight, or an estimated cost of around $40. So if we compare the AAM future market to the evolution of the cell phone, let's say, we have seen the cost transform over time, right? For my STEM math students out there, consider these stats. The first cell phone was introduced in 1973 and weighed approximately 6 pounds. And by 1983, the first mobile phone would cost $4,000 or $11,000 today, one cell phone. So cell phones have had a tremendously fast adoption rate. In 1990, worldwide, there were 12 million cell phone subscribers, and today there are approximately 4.8 billion users. So for you math students out there, that's over 406 times as many as in 1990. So as we all know, originally cell phones were designed for communication. We have seen the cell phone have multiple technological capabilities, showing apps, etc. And this technology has been worth hundreds of billions of dollars. So knowing that, you can imagine taking your eVTOL to school, parking it at home on your heliopad, or taking it to your job interview in another city or state.
I
Wow,
do have a question, David. I don't mean to interrupt, but I have a question from Kyle. He's asking, how soon could this be ready for everyday use? Now, I know, David Zahn, you said, it could be as soon as 2025 where it's starting, but is that for everyday use, or that's when it's just being introduced into society?
Well, Deb, that's actually one of the things we're researching right now, and it's called a UAM maturity level, and they're levels 1 through 4, and those rely on different things as far as autonomy or social acceptance. And so different use cases would be maybe a public service, looking at emergency first response, like that medevac or EMSA transportation, and then ultimately going into corridors where you're having one-off transportations from one site location with a prescribed path to another site location. And then ultimately getting into that ubiquitous travel where everyone's moving them like taxis and going all different directions, as you've seen in some of the futuristic movie states. So I would say the first use cases would be that 2025, where we're looking at very prescribed paths along the ground, and one-off A to B locations. So maybe not ubiquitous travel right away, but hopefully that answers your question.
Yep, I think Kyle will be happy with that one. Thanks.
Yeah, thanks so much for those questions. Definitely keep them coming. Let's take a step back here for a moment, and let's talk about these vehicles and how they're going to be flying. Let's hear from Andrew Lind about how these future forward vehicles are going to fly.
Sure. So with all aircraft, we have 4 forces of flight that govern how it's going to fly. So here we see a futuristic AAM vehicle that when you first look at it, sort of looks a little bit like a helicopter and a little bit like an airplane. And when it's on the ground here, the only force of flight that's acting on it is weight. And so that weight includes the airframe, the payload, the rotors, the motors, all the bits that make up the airplane or the aircraft. So engineers work really hard to make the aircraft as lightweight but as sturdy as possible. So we see weight here with this big red arrow pointed down because it's due to the acceleration of gravity. So in order to take off vertically, which is a big advantage of these advanced air mobility vehicles, we have those 8 rotors there that generate thrust. So in the next slide, I show the vehicle taking off and hovering with the 8 rotors generating thrust, a vector or an arrow pointed upward to generate that force and help support the aircraft in hover.
Let me ask a question while you're on this slide, Andrew, because you said the thrust is what's moving it upward, but with the 4 forces of flight, why would that not be lift, which is moving it upward, and why would that be considered thrust?
Right, so the direction of thrust depends on the orientation of the propulsors. So in this case, our propulsor is those 8 rotors, and they're pointed in such a way that thrust acts up. We usually see thrust act forward, but for this vehicle in this phase of flight, with those propulsors, we see it pointing upward. But you're absolutely right. We normally see lift act upward, and that's why we have that wing. So in forward flight, which we see here, the vehicle is now moving toward the direction of that big white arrow, and lift is now being generated by that wing. And the wing only generates lift when it's moving forward through the air. It won't generate lift when it's just sitting in hover or on the ground. So we need to be moving forward to get lift. And in order to push forward, we see that there's thrust being produced by that pusher propeller in green on the rear, pushing the aircraft forward. And finally, the last force of flight is drag. That's in yellow on this slide. And drag is due to friction of the air over the aircraft as well as pressure from the air over the aircraft. And engineers work really hard to try to streamline aircraft, make them very low drag so that they fly very efficiently and save energy.
Well, Nikki, can you explain to us with this VTOL how that differs from the commercial aircraft during takeoff?
Yes, that's a great question. So if you've ever been to an airport, you've probably noticed that there's these big runways that the airplanes need to take off. And that's because they need to generate enough speed in order to lift off from the ground. But if you've ever seen a helicopter take off, it just takes off vertically. So these VTOL vehicles, which VTOL stands for vertical takeoff and landing, are able to take off vertically. And as Andrew showed, that's because they have things like the 8 rotors on the last on the vehicle that he showed that allow it to just lift up vertically. So because we have this capability, instead of having airports as before, we can actually maybe have something called vertiports. Similar to how helicopters use heliports in order to take off and land, vertiports can be used. And this is really great because they don't take up a lot of space and they can be put on top of buildings. And this means there could be more of them.
Well, it sounds like these are going to be a great asset once they're actually introduced into the communities. But what kind of challenges are we going to face as a community once these are approved for use?
So I'll jump in and say that Nikki just talked about the vertiports, and that's where all these vehicles are going to take off and land. And some of those might be made out of existing airports and existing facilities, but some will need to be made from scratch. And so it'll be a challenge to figure out how and where to put those vertiports and provide them with enough electricity, because a lot of these vertical takeoff and landing VTOL aircraft are actually electric vertical takeoff and landing, eVTOLs. And so they will require charging to recharge their batteries, and we need to figure out ways to get all that electricity to the vertiport. So that's one challenge, is figuring out how to get the charging stations for these eVTOLs. And another challenge that both Nikki and I are working on is making sure that these vehicles are quiet. So we want to make sure that they don't disrupt communities, that it is a benefit to the communities, and they can utilize all the great services that David talked about earlier, and just have it blend into their background without noticing them.
Well, we're definitely looking forward to having these be part of our daily life. So there's obviously more aircrafts that are going to be introduced once all of this is taking place in the near future, like air taxis and package delivery vehicles. So it's going to be a little confusing for us. Nikki, I'm hoping you can help define the difference between a drone and, say, a UAV versus a UAS. Can you explain a little bit more about that?
Yeah. So, the terms UAV, UAS, and drones are going to be used as these vehicles all are going to be as part of the AAM. So in the next slide, I just wanted to show what unmanned aerial vehicles are that there are aircraft that can fly without a pilot on board, meaning that they fly with either a pilot controlling them on the ground or they're autonomous. Even though they have unmanned in the name, they actually there's always a human involved in controlling them. The word UAV is actually one piece of the concept of an unmanned aircraft system. So in that picture right there, I just have two UAVs, and now we have an unmanned aircraft system. Is when we fly the UAS, we're including all the components that are part of making it successful to fly, meaning the pilots on the ground, the programmers who program the vehicle, the equipment, software, and radar and GPS, and all of these things work together to make it a successful system. So we refer to them now as UAS. And then I also wanted to clarify too, the word drone, which has been used a lot. That is a term that has been used for years, for decades, for a variety of vehicles. But we like the term UAV because it's a more technical description of the unmanned aerial vehicle. But it is important to note that they have been called drones by a variety of people. So you just have to, see how you just have to kind of keep that in mind, that there's various words. So.
Yeah, you got UAV, UAS, element of P. It's just kind of like a alphabet soup on this end. So, are all these terms and acronyms necessary, and are they going to remain the same? I mean, AAM. I mean, it's an entirely new concept.
Yeah. So, because it's a new concept, there's all these new terms. It's important to know that the UAVs have been around for a long time, but as they're being applied now towards the AAM context, it's important to have, these terms like UAV, UAS to just explain that, the vehicle is just part of a larger system, because they have to fly in large cities. And so the biggest thing to remember is that even though we have the word unmanned in there, there's always a human involved in the system. But there are as this is an evolving as this is an evolving industry, the names are changing. And, I think I've heard unscrewed aerial vehicle is another term, and remotely piloted aircraft. It really just depends on, where things go and how they're applied. But yeah, so I guess the answer to the question is it could change. But yeah.
Let me interrupt again. We have another question from Kyle Kolzinski. Going back to the cost, I know, Julie, you were saying that the price could be as little as $40 for a ride when you're talking about the air taxi. But he wants to know if one day he'll be able to afford his own, or if it's going to be just commercially owned where you can just purchase a ticket.
I think that is a great question, and I think he's right on the target. I think just like anything else we've seen through time, whether it be cars or whatever else we've used to people own their own small planes. Some people have the luxury to do that. But I think these will be, yes, available to the regular person like you and I. I've read some statistics that this industry over time will be a $1 trillion industry. And I would imagine, just like we're seeing the electric cars today, I would imagine these little eVTOL vehicles will be produced. The supply and demand shifts. And more people want these vehicles. We'll see, maybe these vehicles in our garage someday soon. So definitely, I agree with his comment and his vision, and I do agree that we will see these in the consumer market.
Well, I will have him start saving his pennies.
Sure.
Hey, thank you so much, Deb. Now, if these actual vehicles are going to be flying over our heads every day, what are some of the benefits to AAM?
Well, Dave, I can talk about that. There's several use cases that these UAVs and UAMs can take when we're looking at package delivery and cargo services. We have medical provision, so as far as bringing critical supplies to urban communities or cut-off communities from natural disasters. We also have general aviation. Our people are sporting with these aircraft. We have emergency management, such as search and rescue, putting FLIR or infrared camera systems on these vehicles. And then we also have inspections and surveys. So looking at critical infrastructure for downtown areas, bridges, or even oil rigs that may be offshore. And then ultimately, this culminates into that air taxi model, where we look at the initial use case for a small drone, moving across a landscape to maybe a large air taxi system moving into a urban environment over traffic and in between buildings. So this is a very interesting model, and I think that the subscribers and the STEM stars that are listening here can see, a 6-pound drone use case be applied and those same aerodynamic factors researched to get a 7,000 or 6,000 pound UAM quadcopter for a compensation for hire, a cargo or air taxi service.
There's a lot of uses for these drones, UAS, UAVs. I can't wait to start seeing them in our skies. But where I live, I look out in the sky and I don't see anything out there flying. So when are they going to be implemented? When am I going to start seeing them out in the sky when I go outside and look up?
Well, Deb, I can jump on that. I think David's video there was great. It showed a lot of great applications. I saw firefighting. I saw inspections and search and rescue and delivering medical equipment. I know that even 2 years ago, there was a successful flight for a kidney transplant up in Maryland, where a UAS vehicle successfully brought a kidney for a patient who needed transplant, and that operation went through. So that was an introduction to the great applications that these smaller vehicles have provided and are providing right now. And we might see them starting to be more and more prevalent because we talked about cars and cell phones and how quickly those took off. In the early 1900s, all cars were, the cars didn't even exist. We had horse and carriage. but then very quickly it turned over to automobiles. So we might see that very rapid acceleration in adoption of these types of vehicles, doing missions like what David just showed in that video.
Well, I'm going to make some space in my garage so that I can have one and have some room in there starting in 2025. So the other question is, how is it going to make my life or your life easier on an everyday basis once they are implemented?
Yeah, Deb, these technologies will truly impact the way we commute, work, and live. So right now, most people make decisions on where to live based on their proximity to family, friends, and work. VTOLs and drones will make it possible to reach people in places wherever they are. I also thought of education might not be limited to one location. So perhaps in the future, we will have alternate learning options like signing up for a class with a top professor in another city, or taking a hands-on course or lab in a different state. For those studying climate, this mode of transportation will reduce emissions and our country's reliance on diesel fuel, since they will primarily run on batteries. Dozens of startup companies are competing to develop commercial jetpacks and flying motorbikes and personal air taxis. I mean, imagine being a paramedic and using the jetpack for search and rescue missions. They're delivering critical care services to remote locations, as Andrew said, or being able to to go to school, taking this new mode of transportation. Think about how we eat or the things we like to do, whether it's getting your local pizza from our favorite pizzeria or the opportunity to try authentic food outside of your vicinity. Maybe it's bagels in New York, lobster in Maine, Gulf shrimp in Florida, or going to see a performance in another town or city. I think the possibilities are endless.
That does make things so much more exciting. So the future of AAM seems promising and even more promising for our viewers. Can you all take a second and share what potential careers are going to be available in the distant future?
Sure, I'll start, Deb. Advances in battery energy density, materials science, and computer simulation will pave the way for so many new and exciting careers. So for those of you who are pursuing non-technical STEM paths, there will be opportunities and jobs related to communication, how we communicate with the public and the government, such as regulations get made regarding and surrounding this industry, will be very important as we create visual aids, communication on social media, educational material that will come about from the AAM industry as it constantly changes and evolves. IT positions will expand and be more in demand, such as computer modeling and simulation work will be needed, as well as programming and coding. Positions in human resources for hiring and training all of these new people entering this emerging market. Data analysts will be needed to track budgets and trends, and business integrators, the glue of the organization, folks that are accountable for profit and loss results and execution of the business plan. I mean, everything from manufacturing to maintenance, the supply chain, parts acquisition, the list goes on and on and on.
Yeah, I think those are a lot of really great examples, Julie. And I'll just build and say that we will need a lot of engineers. There are so many designs out there for advanced air mobility vehicles. We talked about small scale vehicles, we talked about eVTOL vehicles, but there's also medium range vehicles, 200 to 300 mile range vehicles. There's just a whole host of new types of aircraft that we need engineers like you watching to help design and build. And so engineers would work on figuring out how big the wings need to be, how big the propellers and rotors need to be, and they would also design the structures and start thinking about how to put pieces of carbon fiber together to make these vehicles. So we need lots of engineers for design and building.
And I'll jump in here. As Andrew said, there's going to be a lot of new designs as we have these UAS take people and packages to the sky. But that means we're going to also have to have them be tested and researched by engineers to make sure that they're going to integrate into the airspace safely. We're also going to need certified pilots to be able to fly the aircraft from the ground, because pilots are part of the unmanned aircraft system. Even if the vehicles are autonomous, we're still going to need programmers who ensure that the vehicle will fly safely and stay on its path. And then, as we talked earlier about vertiports, as they pop up in the cities, we're going to need personnel to work and manage these vertiports, just like the airports today. So since cities are going to now be part of the airspace, designers will need to make roadmaps to know what paths they can take. So there's just so many opportunities that are available, and those are just a few.
Yeah, that's great, Nicole. And so, as he's one of the panel members focused on very detailed components of this new trade space, I'm going to talk about more of the ecosystem. And so one of the things we're researching are how do we act as an airspace manager? And that's going to be a very big role as far as being a dispatcher or operator or a fleet manager for that airspace, much like an American Airlines or United flights or Delta flights are reimagined in scheduling and flight planning for moving people and even targeting a multimodal service. So getting an autonomous car, coordinated with that vertiport to get on an autonomous vehicle to go to an airport and get a transatlantic flight. Another one would be an air traffic controller. Again, as we reimagine this uncontrolled airspace where we're looking at small drones, medium-sized drones, UAS, UAM, general aviation traffic, helicopters, and fixed-wing aircraft operating all in the same space in a three-dimensional market. So if you imagine a roadway system with street lights and highways and on and off ramps, they're two-dimensional. And so when we're looking at making a three-dimensional roadway system, we're going to need air traffic controllers that can manage that. And then ultimately, we want an airspace architects that can build that. So they want to build those hamster tubes in the sky and have an airspace manager coordinate when people are going to access those, and then have air traffic controllers coordinate how they're going to turn those on and off. So deconflict the traffic. So look forward to having you guys out with us.
Yeah, definitely. Thank you so much. There was a question came in from Fran B, and this person is basically taking us back to earlier in the program. What are some actual pros and cons of advanced air mobility? Andrew?
Well, I'll just sort of recap some of the pros that we've talked about. I think that we're trying to make AAM an accessible new mode of transportation that can be used by everybody. That it's not just for a select few people, that it really is something that gets integrated into people's everyday lives. So I think that is one of the biggest pros in the column for advanced air mobility. We also heard Julie talk about the sustainability aspect, that this is an opportunity to create a new mode of transportation that doesn't rely on fossil fuels. And so something where we can use sustainable energy to generate the electricity and then use them to charge and use for flying all these electric vehicles. So I think those are the two big pros. And I honestly, I would have to think about some cons, but maybe that's because I'm biased.
Nicole?
Well, I guess just a few challenges, not say cons, but because we have these new vehicles, they're so their designs are so different than what we've had before. We have to figure out ways, to integrate them. And when you have so many vehicles, a concern could be two biggest concerns are safety and noise. And so, these are just things that we have to keep in mind when we're designing these vehicles, and we have to do research. And it's just more, we're all working towards this, and there's going to be plenty of opportunities for people to work on this. But yeah, we just need to make sure that these vehicles are safe and quiet as they can be.
Julie?
Yeah, I both David and Nicole kind of said what I was going to say. I think the focus, it's not so much a con as others have said, it's more NASA and the FAA and other organizations that are involved, their prime focus is safety, right? So they want to make sure this is a safe alternative transportation option. As I said earlier, NASA's all about testing, so it will not really be rolled out to the general public until they're 100% sure that it's safe and efficient and effective. And, should anything go wrong, they have a plan B and things like that. So the focus is primarily not just the technology and advancements on how we're physically going to create the assets and create the modes within the airspace, but the safe, how are we going to safely do this? And then just the amount of air traffic, right? How are we going to safely control that? And so this is all being looked at. I think David said before, this is really a system that we're working on. We'll be hearing a lot in the next couple of years about the vehicles that are being produced, but it really is, keep in mind, it's an entire system from A to Z, and safety is always number one.
Absolutely. And student online, Kyle, basically is asking how many of these vehicles are going to be flying at the same time, and are these going to replace the automobile?
I could take that one. Like you said, we want to look at that integrated modes or models in which the vehicles are intersecting with aircraft. So traditionally, aircraft just take off from airports, and we may have a helipad sprinkled through the city every once in a while, maybe near an airport or maybe a hospital. But the idea of taking away cars, I don't think that that's going to be 100% the case with the Jetsons or maybe Star Wars. If you've seen that, it's a little more up to date for our viewers here. But what we want to do is create a mode where there's a seamless transition where they're working together, that we don't necessarily have to put gates around airports and security checkpoints and have it very cumbersome for the user and traveler to get on a vertical aircraft or on a fixed wing aircraft going where they want to go. And so when we're looking at the safety aspect, safety is the number one priority for aviation. And a lot of times with vehicles, it is a cost effective is the number one thing. And so what we want to make sure is that as these vehicles intersect with a airspace, that we maintain safety as the number one priority, and then economics and scalability will follow from that.
All right, excellent. Thank you all for answering those questions on this end. Special thank you from Rosario, who says, thank you so much for the opportunity to be able to talk with you about this new advanced concept on this end. All the careers that you have spoken about are very exciting. I really encourage all the students to look further into advanced air mobility. In fact, thanks once again to everybody for sharing all this insight into the many future careers here at the National Aeronautics and Space Administration. We're out of time at this point, but before we go, we do have a student challenge for everyone. And I just wanted to say, hey, today is the day that you can start seeing yourself here at NASA. So explore your career today by learning from the pros and their experiences here at the agency. So on the NASA STEM Stars site, you can begin learning more about the amazing careers in science, technology, engineering, and math. You can see the link there to the chat so you can actually begin that. And we hope that after you read and after you actually get the opportunity to see many of the exciting videos on there, for you to share what you learned with us at #NextGenSTEM. So 2 really cool things before we wrap up. I want to say thank you so much to everyone for attending today's event all together and for doing what you do to make advanced air mobility a reality. So we appreciate the time and the dedication that you put in today's program. Now, lastly, don't forget to join us for our next STEM Stars episode on June 30th at 2 p.m., where we're actually going to learn more about the James Webb Space Telescope with Kenny Harris. So thanks to everyone for attending. Don't forget to subscribe, and we will definitely see you all next time. Thank you so much, and have a great day.
Bye.
Thank you.